Re-
Hello, everyone. So it's a big pleasure to just participate on the second international conference on big data, modeling, and machine learning. So the title of my work is RNN Classifier to identify the influence of Oud Master on the way to play of Oud player. So let's start. Introduction. The Oud is the lute and the guitars for it feather. It's a fretless string instrument that is being used to in several Oriental music styles. In this work, we propose a classification model to identify the degree of influence of master styles on the oud players. To do that, we chose three famous oud schools: the Oriental school, presented by Farid Al-Atrash; the modern school, presented by Nasser Shamma; and finally, the Iraqi school, presented by Munir Bashir. Our approach is to propose a model that provides audio from the musical components of the three Oud Masters notes above. Distinctions and play style can then be identified for each master, showing holes and alterations, and then predicting how Oud Master play affects the Oud player. The impact percentage helps to classify the Oud player according to playing style. Our proposal focuses on 6K components, namely audio, segmentation, mathematical attributes, analysis, extraction, standardization, and data normalization, attributes, selection, and the use of the greatest precise algorithm and depth classification method error, and finally, the prediction. The diagram illustrating our plane appears in the following figure. So like you see here, we start by and our inputs. We have audio signal and we do a segmentation. After we do extraction of attributes and selection of attributes by using filter and this step. Before this step, we do normalization and standardization, and finally we do classification to do a prediction. So let's start by explaining what is audio segmentation, this step. So the fragments are divided into different periods between 5 seconds and 100 seconds. Then the whole of the proposed model classification algorithm has been completed in a number of tests in order to build the maximum precision time frames. Duration with the perfect time is 5 seconds. Extraction attributes. Our method consists in exploring the parameter of an audio signal via mathematical equations of signal processing. A lot of information has been extracted with the help of signal processing elements such as zero crossing rate, energy, entropy of energy, spectral centroid, spectral spread, spectral entropy, spectral flux, spectral loss, MFCCS. So like you see here, the other step is normalization and standardization. So auto-learning algorithm will not function correctly without normalization. The range of all entities must therefore be normalized to ensure that each entity leads to the final interval approximately and proportionally. We converted then the data to a level between 0 and 1 using the formula in order to make better use of the information generated and start reducing the range of value. So this is the equation we use make input information between 0 and 1. Selected attributes. And this model, the univariate feature selection uses certain statistical tests such as chi-square, f-test, mutual information to determine the force of the connection among each individual factor and the target variable. The characteristics are classified in accordance with this trait. With the results, all functions are detected from the current function space, other than a predisposed number of markers. The other characteristics are then used for the training, testing, and the validation of machine model. So, like you see here on this figure, so this is excuse me, this is the selected attributes algorithm. Classification algorithm. In this part, we choose to design a deep learning based classifier RNN to produce performance with greater accuracy after passing all segmentation, extraction, normalization, and parameter selection steps. For training and for testing, the data was split into 80% and 20%. After testing a number of training opportunities between 10% and 90%. This division is the best solution. Accuracy established is 73%. Process implementation. The following table shows the pieces used. So we use for each Oud Master. So duration we have for Farid Atrash and Munir Bashir, like you see here in this table, and we split data to from a 5-second from. So we have this number of frames here. After testing a series of differentiation times between 5 seconds and 100 seconds, we choose a 5 seconds time for every piece to discover the perfect choice. So finally, we have for 100 epochs, accuracy is 73%, and loss we have 58%. So like you see here on this picture, the accuracy obtained, and this picture we have the loss for 100 epochs. Conclusions. In this manuscript, we presented a model of categorization of the effect of Oud Master on Oud players. This model is based on a deep learning approach, including an input layer, a middle layer, and output layer. The practical results show that the system is able to classify according to a rate of accuracy equal to 73% and loss equal to 58%. This result remains to be improved. That's why we opt on the perspectives of conceptualizing other models in order to reach an accuracy more than 90% and loss less than 20%. And finally, thank you very much for your attention.